Question 13 is a standard form question, and although it is standard form, you need to know your index laws. So work out 2.5 times 10 to the power of 9 divided by 5 times 10 to the power of 3. In cases where I'm multiplying or dividing by standard forms, I need to split the number values from my powers of 10. So I'm going to deal with these first. I've got 2.5 divided by 5, and over here I'm going to take my 10 to the power of 9 divided by my 10 to the power of 3. So I'm going to treat these as two separate sums for the time being. Now this is a non-calculator paper. This is a non-calculator paper, and whilst it looks difficult to do 2.5 divided by 5, if you consider that that's equivalent to something over 10, which is 5 over 10, then you realise that that is actually equal to 0.5. So 2.5 divided by 5 is 0.5. You can think of it, if you want, as £2.50 divided by 5 people is going to give you 50 pence, but you need to be quite comfortable with quite tricky divisions and fraction equivalents. So I know my numbers are going to give me 0.5. Now over to my index laws for the powers of 10. 10 to the power of 9 divided by 10 to the power of 3 is going to give me 10 to the power of 9 take 3, which is 10 to the power of 6. So at this point, I'm going to put my two answers together now. I'm going to have 0.5 times by 10 to the power of 6. Now, whilst that looks like standard form, it's a trick. That is not standard form. Standard form is always written as a number between 1 and 10. So it would need to be 5 or 5.0 if you need that as a visual prompt. Now, because I've had to change from 0.5 to 5, and that change has been making the number bigger, it means I lose a power on my standard form answer. So it's 5 times by 10 to the power of 5. Now the mark allocation is quite simple for standard form questions. You get 1 mark for either working the number out, or you get that same mark for doing the index laws. So that's your first mark. Now your second mark comes from having the correct answer with regards to decimals in the right place. If you were to leave it like that, you would still get 1 mark, but in order to get 2, you would need to have it as standard form. Question 14. This is a lovely little algebra question. The diagram shows a pentagon. Now this doesn't look like a pentagon. In fact, I think it looks like a house, because that's how we used to draw in houses. But remember, pent means 5. So it's 1, 2, 3, 4, 5. It is a 5-sided shape, so that is a pentagon, even though it's not how we're used to seeing it. Now it's got this notification on the side, diagram not accurately drawn. That means you cannot measure anything. It then says all measurements are in centimetres. Show that the area of this pentagon can be written as. So this is a show question. And they want us to show that the area of this pentagon can be written as that. So they've given us the answer. They've told us the area of this pentagon is that, and they want us to show how that happened. So first thing I'm going to do is look at the shape. Now it's an area question. I do not know how to find the area of a pentagon. But what I do know is that if I was to break this into 2 shapes, I would have a rectangle and a triangle. And I know that the area of a rectangle is base times height, and the area of a triangle is half of the base times height. So first thing I'm going to do is find the area of this rectangle, because it's nice and easy. So I'm going to tell the examiner I'm finding the area of the rectangle. And I know it's base times height. Now the base is 2x minus 2. And it's going to be multiplied by the height, which is 2x plus 1. Now, because these are two expressions, I'm going to write them in brackets, and it'll become double brackets because I need to multiply everything together. So in this case, I'm going to expand this out, and it'll have 2x times 2x, which is 4x squared. I'm going to have 2x times by positive 1, which is positive 2x. I'm going to have negative 2 times positive 2x, which is negative 4x. And I'm going to have negative 2 times positive 1, which is negative 2. I'm now going to collect and simplify my terms. There are no other x squared terms there, so that stays on its own as 4x squared. I have got a plus 2x there. Don't forget your sign belongs to the number. So there's my plus 2x there. There's a minus 4x there. So positive 2x, take away 4x leaves me with negative 2x. I've then got that negative 2 on the end that I can't do anything with. So I've gone ahead then and found that the area of my rectangle is 4x squared minus 2x minus 2. Now I'm going to find the area of my triangle, and I'm going to put the formula down again. It's half of the base times the height. And let's have a look at my triangle. Now I know the base is the same as it was down here, so that's 2x minus 2. I can write it there if I want. So that's 2x minus 2. Now I need the height. And it's always the perpendicular height you want. You never want a diagonal line for the area. Now, I'm going to need to work this out because I know that this whole height of the whole shape is 3x plus 5. And I know that the height of the rectangular part is 2x plus 1. So I need to find what that height actually is. In order to find that, I need to do the 3x plus 5, which is the height of the whole thing, take away the 2x plus 1. Now the way I've written this out suggests that I've got a negative 2x and a positive 1. This isn't the case because you have to take away the whole thing, the 2x and the positive 1, which means that that is a negative 2x. And that, even though it was a positive 1 there, the fact that there's a negative now affecting it means it's going to become a negative 1. So what I've actually got is 3x plus 5 minus 2x minus 1. So I put my x's together. I've got 3x take 2x is going to give me 1x. I've got a positive 5 take away 1 leaves me with positive 4. So the height of my triangle is actually x plus 4. So now I can find the area because I've got my base, which is 2x minus 2, and my height, which is x plus 4. So the area of my triangle is going to be half of 2x minus 2 times by x plus 4. I'll deal with the half in at the end. I'm going to expand this bracket out first. 2x times by x is 2x squared. 2x times by positive 4 is positive 8x. Negative 2 times x is negative 2x. Negative 2 times positive 4 is negative 8. Collect and simplify. Positive 8x, negative 2x. So my 2x squared doesn't go with anything. My 8x, take away 2x, leaves me with a positive 6x, and then I've got my negative 8 at the end. Keep in mind I need to half all of that. So half of 2x squared gives me 1x squared. Half of positive 6x gives me positive 3x. And half of negative 8 gives me negative 4. Now I've got, and clearly stated for the examiner to see, the area of my rectangle and the area of my triangle. I can go ahead and find the total area. And my total area is going to be my 4x squared minus 2x minus 2 plus the area of my triangle, which was x squared plus 3x minus 4. So I've got the area of my rectangle added to the area of my triangle. So when I add those together, I get 4x squared, add x squared, gives me 5x squared. I've got negative 2x plus 3x, leaves me with a positive 1x. And I've got negative 2, add negative 4, gives me negative 6. So there's my total area. Now, if you remember correctly, this was a show question. So I can look back and check, have I successfully answered that? Here's the question. Show that the area can be written as 5x squared plus x minus 6. Yes, I've shown that. Brilliant. There's 4 marks. Now, the mark scheme breakdown for this is quite logical, really. You get 1 mark for finding the area of the rectangle. You get the second mark for finding the area of the triangle. You get the third mark for showing you add in those 2 areas together, and you get the final answer mark for getting the answer correct. So remember, find what you think is the area of the rectangle, find what you think is the area of the triangle, add them together and you will get that method mark.